All right, this is our second and final mini lecture for Module 1. And in this one, we're going to extend and relate the knowledge that we played with a little bit in the first lecture, where we looked at the relationships between the arithmetic operations, addition, subtraction, multiplication, and division. And now we're going to extend that to the idea of exponents, and then we're going to talk about finding the missing parts in an exponent expression, and those inverse operations and those shortcut relationships that we found in the first lecture are going to really help us. So first of all, let's just talk a little bit about exponents. So in the first lecture, we saw that there was a shortcut relationship between addition and multiplication, where multiplication is a way to show adding over and over, repeated addition. And also the relationship between division and subtraction, where dividing is a way of subtracting things and putting them into equal groups over and over, so repeated subtraction. So exponents are an example of another type of shortcut for doing a repeated operation. And in this case, exponents allow us to show repeated multiplication. Another thing that we looked at is there are different ways to use different symbols to show multiplication and division, and one of the ways we saw was this little dot right here. So this is a shortcut way for showing that I'm going to do repeated multiplication. So the second power of 2 is 2 times 2. And when I start getting bigger and bigger exponents, this one shows me that I'm going to multiply 2 by itself 6 times. Well, what if I had a situation where I needed to multiply 2 by itself 64 times? I don't want to write it this way anymore, and I'm really glad that I have this shortcut way of showing repeated multiplication, and that's what exponents do for us. Let's take a look at a common, this is a Texas Instruments scientific calculator, and we're going to look at just doing these as a calculator skill. So remember, this one means, and remember this is another way I can show multiplication, is using the parentheses. This tells me to take the 5 and to multiply it by itself 8 times. So let's see, 1, 2, 3, 4, 5, 6, 7, 8. And that makes me really glad that I have this shortcut way of writing it. And let's look at how to do it on a typical scientific calculator. So first of all, I'm going to enter the 5. And there are 2 places I can do things with exponents on this calculator. One of them definitely looks like an exponent, and this allows me to do the second power of anything. And one of them doesn't look like an exponent at all. It's the one right above it. This is called a caret. And watch what happens when I hit this. Right now it's flashing right next to the 5, but when I hit it, it pops up into that exponent spot. And just something to keep in mind is that if I were to keep adding stuff, notice that it's all still up here in the exponent. So as soon as I get done, so let's do 5, and I'm going to use the caret and the exponent of 8. I don't want to be flashing up here anymore if there's other stuff I need to enter, and so I can use this direction pad and I can get over there. And of course that's going to be different on different calculators, but this is pretty common. Then this one, I'm just going to go ahead and hit enter. And 390,625 is what we get. So then I encourage you to pause the video here. Our Canvas course does have a link to a scientific calculator. You probably also have a scientific calculator on your phone, or maybe you have one from a different math class. And you can also find a lot of scientific calculators online. So go ahead and pause it and check these, and then we'll take a look at them together. All right, so looking just as a calculator skill, I want the 4th power of 11. and that's going to be 14,641. And another thing to notice is these numbers get big pretty fast. The first multiplication was 11 times 11, which is already 121. Then I took 121 and multiplied by 11 again, and then I took that product and multiplied it by 11 again. And so with exponents, in this case, because all our numbers are positive, we're looking at exponential growth, and it's growth because these are all positive. We're going to see later in the course that if we have things that are decreasing, that's going to be called exponential decay. And just the thing to keep in mind right now is that the numbers can get big fast with this repeated multiplication. All right, this one just asked me to do 15 times 15. And so we're going to do 15 and then the caret 225. This one asked me to multiply 17 by itself 3 times. 4,913. And then now we're going to multiply 9 by itself 5 times. 59,049. So as you're doing those on the calculator, if you're not getting the same results make sure to let your instructor know, because this will largely be a calculator skill. But I want to make sure that intuitively it makes sense, because later on in the course we need to extend this knowledge to relate to roots and to something called logarithms. Okay, let's talk vocabulary for a minute. We need to understand and agree on the names for the different parts of an exponent problem so that we can use the vocabulary and everybody understands what we're talking about. So first of all, the number that we multiply, this is the number which is multiplied by itself, is called the base. And that's important in other contexts as well, when the base is not necessarily in the same place in the problem. Then the number that tells us how many times to multiply, that's the exponent. And then the result is called the power. So let's look at some examples here. In each case, I'm using a base of 2. And so I would say the first power of 2 is just 2, when I have the 2 just one time. The second power of 2, which is equivalent to 2 times 2, and let's make sure, so this would look like the first power of 2 is 2. The second power of 2, which is 2 times 2, is 4. The third power of 2, 2 times 2 times 2, is 8. The fourth power of 2, 2 times 2 times 2 times 2, is 16. And then the fifth power of 2, we would multiply by 2 again, we'd get 32. The sixth power of 2, we'd multiply by 2 again, we'd get 64. So when you're looking at these, let's take the third power as an example. Here's the base. Here's the exponent. And here is the power. And that's how I would read it. The third power of 2 is 8. So just to make sure this is comfortable, let's just do a little practice for a minute identifying the parts of the exponent problem. Feel free to pause it here and go ahead and try it in your notes, and then we'll check these together. So let's mix it up a little bit. Let's not do them necessarily in the same order that they're listed here. So first of all, let's identify the exponent. The exponent is the 5, and that tells me that I'm going to multiply the base of 3 by itself 5 times, which would give me the fifth power, which is 243. So the fifth power of 3 is 243. Here, the power, 121, that's the second power, so we have the exponent of 2 on a base of 11. Okay, and then we're going to relate this to our knowledge of working with t-charts. So let's review just for a minute. Remember, the kind of relationship is named here, and it's implied that the inverse, remember a sum is addition, that this chart will also show us the inverse of subtraction. Product is multiplication, but this chart will show us the whole relationship, so it'll also show us the inverse of division. And when we have those things working together, if we're strong in the knowledge of one relationship, for example, multiplication, but maybe not as strong in our knowledge of division, you can use the strength of your knowledge of multiplication to improve the strength of your knowledge of division. So to sum, all I'm doing is finding all the ways. So I could do 0 plus 4, and then I can see the inverse relationship. If 0 plus 4 is 4, then 4 minus 4 is 0, or 4 minus 0 is 4. Then I'd have 1 and 3, 2 and 2, and then the next one would be 3 and 1, but we already have that. And remember, it doesn't matter what order you add or multiply in. So 1 plus 3 is the same thing as 3 plus 1, but because we got a repeat here, we can stop because we had a repeat. So stop. We found all the ways that we can get a sum of 4. And then we can see the inverse relationship. For example, 4 minus 3 is 1. 4 minus 2 is 2. Okay, and then with our product relationship, so let's see, we'd have 1 and 12, because 12 divided by 12 is 1. And then this is an even number, and that would be 2. And if I'm not sure, and remember these are called factors when we're dealing with multiplication, I can also, if I can't see this unknown in my brain, I can just ask, okay, 12 divided by 2, and that gives me 6. The next one would be 3 and 4, because 12 divided by 4 is 3, and 12 divided by 3 is 4. Then the one after that's going to be 4 and 3. But again, it doesn't matter what order I multiply in, so this is a repeat. So I'm going to stop. All right, so let's go ahead and extend that. So here's the sum we looked at, here's the product. Now let's look at a power relationship. And its importance with a power relationship, so with a sum and a product, the order doesn't matter. So with these two, order does not matter. But in the last video, I talked about the fact that with subtraction and with division, the order does matter. 10 divided by 2 is very different than 2 divided by 10. So in the power relationship, the order is also important, so we need to read them from left to right. So this is the base, this is the exponent, and this is the power. So here's the base, here's the exponent, and here is the power. So a base of 81 with an exponent of 1 gives us the power of 81. Or I can read it as the first power of 81 is 81. Then with a base of 9 and an exponent of 2, 9 times 9 gives me the power of 81. Or I could say the second power of 9 is 81. Then with a base of 3 and an exponent of 4, I also get a power of 81. Or I could say the fourth power of 3 is 81. So this is cool because just like with these two examples, if we start having kind of holes in our knowledge here, if we picture the relationship this way, it allows us to kind of use common sense and our mathematical sense to figure out what are the missing parts. Okay, one of the really important things in algebra is just the idea of solving for unknowns, and they're not always where you expect. So in this one, we are missing the sum, the product, and the power. And I can just go ahead and remember sum is addition, so I'll just go ahead and add these together. So the missing value here is 4 plus 2 is 6. And that's the same thing as saying 6 minus 2 is 4 and 6 minus 4 is 2. Then when I have the product that's missing, this would be addition because it's a sum. This is going to be multiplication. So 3 times 5 is 15. And then I can also see that inverse relationship, 15 divided by 5 is 3, and 15 divided by 3 is 5. And then this one, the power, this is equal to 6 times 6, which is 36. And then I can kind of mix up the way I say it. So a power of 36 with a base of 6 is the second power, or the second power of 6 is 36. So we can also kind of mix up the way we say it, and it gives us some flexibility if we're missing different parts of our relationship, which is what's happening here. So we're going to extend our knowledge a little bit and think about, okay, what if I have something missing in a different place? In this case, I have the sum, the product, the power, or you might think I have the answer, but it's part of the problem itself that's missing. So here I have to ask, okay, with a sum, which is addition, this is multiplication, and here we're looking at exponents. When we have this sum or addition relationship, well, what added to 7 gives me 13? I can use my inverse and I can say 13 minus 7 is 6. And I can find an unknown in a different place. Okay, with our product relationship, 60 divided by 10, well, remember the calculator is a really good real-world tool. So I'm just going to go 60 divided by 10, and that answers the question, what multiplied by 10 gives me 60? And then I have the whole relationship. 60 divided by 6 is 10, 60 divided by 10 is 6. So let's use our intuition here and let's think, okay, what base, so we have a missing base, what base, if I put an exponent of 3 on it, is going to give me 8? And this is just a little trial and error that I can do here, but I can be reassured by the fact that this power is not very big. So my base must be, first of all, my base has to be smaller than my power because everything's positive. And I'm going to multiply something by itself 3 times. Well, what base could I multiply by itself 3 times to give me 8? And we'll see later in the course there is a way to use roots to do this on the calculator. But for now, let's just use our intuition. So think about it just for a second. What number, if I multiply it by itself 3 times, is going to give me 8? Well, it can't be 1, because the third power of 1, or any power of 1, is just going to be 1, because if I multiply 1 times 1 times 1, I only ever really have 1 time. So let's try 2. So what if I had a base of 2 with an exponent of 3, and that does give me 8. So that's my missing base. Then if I hadn't tried 2, and I tried a base of 3, and I put the exponent of 3 on there, I get 27, which is too big. So I have to go back down to a base of 2. 2 times 2 times 2 is 8. So I can use my intuition to figure out what's missing if I have a missing base. Here, even though what's missing is on the other side, since the order in addition and multiplication doesn't matter, I'm still doing the same thing. I'm using the inverse relationship or inverse operation. So 15 minus 7 is 8. 20 divided by 4 is 5. But I invite you to just take a second and look at that one. And what is it that's missing? Well, here's the base. Here's the power. So what we're missing is the exponent. And here we can just kind of use our intuition again for our mathematical sense. How many times do I have to multiply 3 by itself to get 9? Well, the first power of 3 is just going to be 3. But the second power of 3 is 3 times 3, which is 9. And that's our exponent. So we'll formalize this a little bit later in terms of math vocabulary and some calculator functions. But for now, I want you to just kind of use your intuition.